Now, next major component is your aggregate, and aggregates are basically around 99% aggregates are inert in nature. So they are not taking part in the reaction. They are as a filler, but still they are very, very important for making concrete for a proper workability, placing, and durability. So those are very, very major role for aggregates. What is aggregate functions? Is a cheap filler, because you can make only any member with only with cement. So that is very costly, and cement having a lot of one peculiar property of cement is shrinkage. Now this fillers basically occupying the volume in the range of 7 to 75%. Imagine that. So important is there. Balance is your cement and water. So it is a very hard material. As I said, cement is a peculiar property is shrinking. It provides volume stability, which is what we need. Actually required for any structure, volume stability is very, very important. So once you have stable volume, you get very good performance in the structure, because volume change in the volume because of the ambient conditions in winter and then summer. Like steel in heat, if you heat it, it expands. When it is cool, it is shrinks. So similarly happening in the concrete also. It is not 100% controlling the volume, but it is very, very minimized, since your concentration is very, very low, because other things are stable in the nature, because it has got very good, very low coefficient of expansion. If you go in the properties of rock, then you will understand this. We are not going in detail of that. You must have studied in geology. And then reduce the volume of volume changes. This gives very good stability in the structure. Also, abrasion resistance. This provide abrasion resistance when you are working for road or factory floor, or your spillway of dam, where a lot of water spill along with the silt, and you say that a lot of erosion takes place. Such cases we need abrasion resistance also. Even the concrete road, you know, say some of the concrete road is eroded very fast. Maybe aggregates are good, but the process is maybe not taken properly. That we'll discuss in subsequently when you talk about hardened properties of the concrete. But most of the abrasion resistance of the concrete provided by the quality of aggregate, because some of the factory floors or where high abrasion is there, we are using even iron aggregate, hematite. Those aggregate also we are using it for to provide more abrasion resistance. As I said earlier, aggregates are occupying nearly 70 to 75% of total volume of concrete. Since they are essentially inert in nature, but they are very, very important for concrete to make a stable volume and achieve the strength. Once you have reduced the volume, you have reduced minimum quantum of your cement. So cement is costliest component in the whole concrete making process, and cheapest is your aggregates. So one has to use optimum amount of aggregate to make a particular grade of concrete is possible. Now these aggregates may come from natural source or from manufactured source. Natural aggregates coming from rock, which are there maybe three geological classification. You must be knowing this: igneous rock, sedimentary rocks, and metamorphic rock. I'll not spend much time on this. This is all details are available. But the basic source of rock is these three. From there, we have produced the aggregate with different mechanism. That we'll discuss. Now, this is the how the aggregate is production takes place. Now, in mines, we have hills where you blast the things, get very good boulders, bigger size boulder, maybe 50 centimeter or 60 centimeter or 90 centimeter, depend upon you. You can go for vibrating feeder, those boulders. In vibrating feeder, what happens is whatever clay is there coated on those boulders as removed in this vibrating feeder. Sometimes they also pour water here to remove that skin in the basically coating of your overburden or in the clay in the mines. Then it's go for jaw crusher. There's reduced to maybe 40 to 100 mm, and from there it's go to impact crusher, and from crusher it is again screen out with whatever sizes you want, 20 mm and 10 mm, and this again is goes to the another vibrating skin where we get around 10 mm, less than 6 mm, and goes for reforming machines. Now you must have seen in Mumbai, we use only a cruststone sand. Some people they call as a manufacturer sand. Manufacturer sand is different than this cruststone sand. Some people also call as a M sand or machine sand. But the real technical term is cruststone sand. And there is a reforming machines are available. So here VSI machines are there, vertical shaft impactor. So once it goes there, it moves and create a fine material with a defined grading as well as defined shape of the material. In total concrete, whatever you produce, shape and particle size distribution is very, very important in concrete. As a QC engineer or as a concrete technologist, one should understand the importance of shape and size of your aggregates. Now, for most of the RCC structures, we are working from 20 mm size maximum to go to the 150 micron as the minimum. Maybe some amount of 75 micron is available. So one has to understand this, and that's a very, very important role for making concrete, making mix design, determining the flow of the concrete or workability requirement, even for the your durability of the concrete, all will depend on the shape of the materials. So yeah, whenever you work as a concrete technology, you have to spend more time on the your how I can get better aggregate or select aggregate such a way that I should get very good shape. This is very, very important in this. Now for our practical purposes, aggregates are divided into two groups. One is fine aggregate and one is coarse aggregate. Fine aggregate earlier we are calling as a natural source when we are calling as a what you call is a sand or river sand, which is coming from river beds. But now that is banned because of the environmental issues coming out in there. So natural source. Also crust stone is also as a natural source because natural rock we are crushing to the size, right from say 75 micron to around 5 mm, 4.75 mm. That is called sand. And material retain on your 4.7 up to 80 mm called as a coarse aggregate. You are not going use up to 80 mm. You are mostly use of the 20 mm size or rather 20 mm. Some foundations may allow to use about 40 aggregate also. So that we need to understand this. So we are dividing fine aggregate and coarse aggregate. Now coarse aggregate size, fine, fine aggregate 4.75 to 0.75 micron, 75 micron, and the material which is written, that's why it is written plus 280 is called coarse aggregate. Very simple definition to understand. There are two groups. One is fine aggregate, one is coarse aggregate. Now, all these requirements or specification of coarse and fine aggregate is also very important code. It is after 1970, 2016 it is revised now. That is IS 383. This code also you must have copy of this always with you. Specification of coarse and fine aggregate to be used in concrete. IS 383. So one is IS 456, then you go for IS 383 because it is latest version has come as 2016. And how to test these aggregates of various tests, we'll discuss those tests also, are given in IS 2386 part 1 to part 8, where method of test are specified. So these also we should have copy. At least we should go once in this to understand what are the proper procedures for testing. Because when you go to the site, the people who are doing the testing, they may be doing by experience, and there are a lot of issues about right from sampling of the materials is also very important. Because large stockpiles are available, in that you have to take very representative sample. So sampling is very, very important for getting a small sample, maybe 1 kg or 2 kg from about 1000 or 2000 kg materials available at site, to have a representative sample, because based on that only you are going to design your mix. So sampling is also very, very important. So we should use 2386 part 1 to 8 for method of test. Now this is also we are taken from your IS 383. This is, as I discussed, rock or called as uncrushed sand. Now in nature what happens, you get crushed stone, whatever you can just crush the rocks and get the required sizes, right from say 80 to say, 150 micron. Or sometimes you get gravels. You are aware about the gravels? Gravels is the basically river bed, coarser material of a river sand. That is gravels. Same size, 40 20 10 gravels. It's called pebbles also sometimes, but the technical term is gravels. So gravels we can use, or we can use combination of this, that is a mixed sand. So IS is not restriction for any material to be used in any form. You can use 100% crushed stone sand, you can use 100% crushed gravels, or you can use mix of these, depend upon their availability in size. Now the blending of size that will come later, but this is available. Then you can come to the manufactured of fine aggregate. Mostly fine aggregate they use as a manufacture other than natural source. So whatever coming from crusher is not the manufactured sand. So manufactured sand may be processed by thermal or separation, washing, crushing and scrubbing. So a lot of industrial waste is available like GBS, granulated blast furnace slag. That is also available, that you can separate it out and use as a aggregate after washing and crushing as desired levels. That is called manufactured aggregate. Also there is a recycled concrete aggregate. Now this area is not yet much popular in India, but there is a huge potential to go for the recycled concrete aggregate. So there is a subject itself, but I am just giving you, these are also aggregate can be used at a certain level of grade of concrete. It has got its own limitations, can be used because we don't have any professional uh, aggregate manufacture for recycled concrete. If you go to the Western countries like Crusher, they have recycled concrete aggregate plants are also available. So they collect the waste or demolition waste from the old buildings and prepare the aggregate sell in the market. Now, how to use those manufactured aggregates is given in table 1 of IS 383. We will not discuss this. I'll just show you the table. You can go through the table. See, this is recycled aggregate. You get the waste from the industry, waste material, crushed it, and you get like aggregate like this. Now, this design process is different than normal process. You have to consider a lot of points when you design with recycled concrete. It has got its own limitations also. So this is the extent of utilization. Iron slag, steel slag, recycled concrete aggregate, the recycle aggregate, bottom ash from thermal power station. These are all your manufactured materials. Fine sand. This is a coarse material. This is fine material. Iron slag, steel slag, copper slag. Now, steel slag is available in here in Mumbai also can be used, but they are given how much to be used in RCC, how much to be used in plain concrete. That is very specified in IS 383 2016. Earlier version, this was not there. So now you can follow this and you can utilize in your concrete. IS 383, in that they are given this. Now in coarse aggregate, we have material which is retained on 4.75 mm sieve, and that is also same on crushed gravels or stone from natural source, crushed gravel or stone, partially crushed gravel, stone, or blending of those materials can be used. All manufactured other than natural sources RCA or recycle aggregate. Now here important note is there, manufactured aggregate like this, whatever we indicated in this, shall not be permitted for pre-stressed concrete. So this you have to remember always. Now what are the deleterious material in this? Pyrites, coal, lignite, mica, shell, laminated material, clay, alkalis, free lime, sea shells, organic impurities. These are the deleterious material available in the fine aggregate, also in coarse aggregate. The table 2 has given in IS 3T what are the materials and what are their limitations, especially for fine aggregates. So one has to test it and then only we can go for use it. So this is the limitations, IS 383 2016. Coal lignite, what is the limits? They are given crushed, uncrushed, manufactured, or crushed, and the coarse aggregate and the fine aggregate. And this is a reference test code. Generally, we do clay lumps and material finer than 75 micron. Here is 3%, and for crushed sand, it is 15%. This one we can remember for this. Whenever you are using crushed sand, crushed stone sand, you can go, this limit has increased to 15%, and for natural sand, it is only 3%. And that is by weight, not by volume. Then other limits are there. This total, it should not go by 5% here as uncrushed. Here 15 plus 2, around 17-18% is acceptable. Now the shape, as I said earlier, it is very important to know shape of aggregate, which is the governs your water demand, pace demand, and performance in the concrete. So flakiness and elongation index is one of the major tests which is given for determine the shape of your materials. So combined limit is now specified as 40%. Earlier code it was not there. Now it is given limit about 40%. Still, though they are given a limit, it is not much mandatory because engineer in charge may take a relax this limit, which is also given in the code. Why? Because If you go for limestone aggregate, you must have seen limestone always come in the slates, in the flat slates. So there, this value goes up to 50 to 60%. Now, when you are working nearby a cement factory where all limestone is available, you'll find your all aggregates also similar in nature. Now, when you go for such material available at site, you must have a proper mix design for this. You have to take care of this proper mix design. Otherwise, you'll have a lot of issues. Or other normal build stone, it is maximum limit is 40%. That one has to understand. This is given in IS 383. Now see the coarse aggregate here. This is a very good aggregate. You can see the near to the angular shape. Angular shape peculiarity is your surface area is minimal. Volume to surface area is minimal. Here you can see the aggregates are, see, elongated lengthwise. Now same size, here the surface area is more. In subsequent slide, I'll just explain this because this is very important in when you are doing a mixed design. Very, very important. This is one of the factor one has to understand very carefully. Now, some of the aggregate, if you see, there is a filling in the aggregate itself. This is a secondary rock. You will find and this filling sometimes are reactive in nature. So when you are using any aggregate from the new source, which is not used for so many years, or new quarry, one has to test this infillings also for alkali aggregate reactivity. See here, see, green color is there, sometimes red color is there, and white quartz or any reactive silica may be there inside, amorphous silica. That is reacting with your cement and having a lot of issue in concrete later on. So before going to make production concrete, you test all the parameters and then only we can go for the use in concrete. There's a test given in IS 2386. This is what sphericity, what you can very angular. This is what we are looking at the aggregate like this. But generally crushed stone will get in this nature. So desirable shape is this. But whenever like this also, we can design a concrete. We cannot reject the material based on only a shape. Then you'll have to do the adjustment in the mix design. See, this is a gravels, rounded gravels. This is subangular gravels, but it is crushed, some of the aggregates. The same gravel which is coming from river beds. If you go to the Himalayas or Punjab, that area, most of the aggregate, because all the rivers, they are having those aggregates there. This aggregate just they screen and use in the concrete. But in our area, generally we use this aggregate, crushed stone, and you rock cut into the desired level of size. That is mainly come in the angular form. But sometimes now we have got very good technology for crushing equipment. Earlier it was not there. We are going only a jaw crushers. Now we have got, as I showed you, is a reforming or shaping material. These equipments are available. They give very good angularity for the aggregates, which is always desirable for good and high strength concrete. As I say, this is desirable and this is less desirable. See here. Now, this will have a lot of issues if you use in concrete because the surface area is very, very large compared to the same size of same materials. Now you'll see how the effect is coming on size. Now here we have 20 mm aggregate. Surface area is 24 centimeter. Volume is same, 8 cubic centimeter. Now this I break into 10 mm. See the surface area, just double, but volume is same. So when you are taking by volume, this is the absolute volume. Your aggregate is same, but surface area is more. Now, when you have a particular proportion of this material using certain amount of cement content and water content. If you change this proportion, your water content will change because your surface area is increased, required more water, required more paste. This you have to remember in your mix design. Why we are insisting that whenever the change of grading, you must change up your water cement ratio. Water cement ratio keeps same, but water content is changing, your cement content will change. These figures always you have to remember when you are talking about concrete. Why we are saying that one source of material suddenly change the another source, the shape of that material may be same or may not be same. If the shape is not same or grading is not same, your surface area will increase or may reduce the surface area having issues. So this important point you must remember whenever you are designing a concrete. That's why we are saying in RMC plant, every day you do the grading and adjust your proportions of coarse to fine. When you talk about packing in next lecture, we'll find that how to go about this. But this is also very important that size is changing because sometimes upon your this stock is exhausted. Now there's no stock and you have to produce a concrete. You have a lot of stock of this. Now earlier using in the combinations, now you are reduced this is not available. You have to use only this. We cannot use same mix design using this material. We have to change the proportions. Looking at the surface area, so much water will increase, so much cement will increase, then so much aggregate I have to use. This is a basic concept. You must remember always size, particle size and particle shape decide the water demand, also decide the amount of paste required for unit volume. Once you able to catch this concept very carefully, is very easy to do the mix designs. Why you get batch to batch variation? Because of there may be change in the aggregate shape and size also. Size will come to the I think next lecture. Now it is time is over. But
Sir, we
yeah,
have few questions also in
yeah,
chat box.
yes. 1 minute. Huh?
Uh,
Let
yeah.
me last slide is there. I'll complete and
Okay,
then
okay,
we'll
sir.
take a check. Similarly, I was talking about flaky material. See, this is a flaky material 20 mm here. Here is also 20 mm, 2 centimeter. But this is angular in the shape. See the area here and see the same material is a flaky and elongated. Is a flat and elongated. Slate-like thing is coming limestone, as I said earlier. So once the source changing, this is the area has increased. Now to coat this surface area, we require different amount of paste content. Now your water cement ratio is fixed. Your water demand has increased. So once the water is increased, you have to increase cement also. And that mostly people are not doing. They are doing only water they increase, don't increase the cement and having lot of issue in concrete. This one has to remember.